Hey, let's do another open top box activity. So this has to do with 2.2 in your homework, task 2.2. Let's take a look at a piece of paper that this time is 10 inches by 8 inches. Sometimes you get paper that's not exactly standard like we did in our first activity. And again, I'm going to ask the same question. What do you think I need to cut away? What size squares in each corner do I need to cut away to get the biggest volume when I fold this together? So again, let's use X. Let's use X and build our formula based on our activity before. So let's build a volume. Remember, this is our base area when we fold up the sides after we cut away the corners. So the base area has a width and a length. A width and a length. The width of that base area starts with a 10-inch piece of paper, but then we cut away two X values, two corners, two X values. So we cut away two of those X's. In other words, our width is 10 minus 2x. Our length is the same idea, but 8 minus 2x. 8 minus 2x. And don't forget our height, in this case, is just x. So let's build a volume function v of x. Our volume function comes from length times width, I usually say width next, width times height, LWH. Substituting in. Our length is over there on the right is 8 minus 2x. Let's put parentheses to make sure we multiply to the next dimension, and that is the width. The width is 10 minus 2x. And then our height is simply x. So this is the formula. This is the function that'll let us plug and chug any value of x to determine a volume. For instance, if I wanted to, I could plug in v of 1. What if I cut away just 1 inch on this one? V of 1, using the equation, everywhere I see x, there's 3 x's there, I'm going to put in a 1. So now it's 8 minus 2 times 1 times 10 minus 2 times 1 times 1. Let's clean that up a bit. That's 8 minus 2, that's 6. 10 minus 2, that's 8. And then times 1, I'm not going to rewrite. So we find our volume is 6 times 8 is 48. 6 times 8 is 48, so we now know our volumes. Technically, it's 6 times 8 times 1. There's our 3 dimensions. And we know our volume's 48. So the question becomes, can we find a bigger box? What X do we cut out? What is the biggest volume we can make? Let's go to Desmos in a minute here and explore that idea. But right now, I want to show you how to clean up this equation and put it into standard form. So right now we have something called factored form. I want to talk about what it looks like to be in standard form. To get to standard form, you need to multiply out all the factors. So if v of x is equal to 8 minus 2x parentheses 10 minus 2x and then times another x. Well, I'm going to use the commutative and associative rules. You don't need to remember those titles, but here's the idea. I'm multiplying 3 things. I can multiply 2 things first and then multiply it to the third item. In other words, I can multiply out these 2 binomials. Those are binomials because they have 2 terms in them. Terms are just values that are separated by pluses and minuses. Little expressions that are separated by pluses and minuses. So these are binomials. You might remember foiling. But I'm going to try to do a different method maybe. So if I'm going to multiply an 8 minus a 2x, I'm going to set it up like a multiplication table, like a times table. So whatever value I see on the top and whatever thing I see on the left, I'll just multiply and put in the boxes like I'm building a multiplication table, a times table. So I'm multiplying an 8 minus 2x and a 10 minus 2x. 8 times 10 is 80. See how I did that like a multiplication table? It's kind of cool. Now I'm going to slide over to the next header over here. That's a negative 2x. I'm going to put the negative on that and call it a negative 2x. That's how it's supposed to be. So multiplied times 10, that's negative 20x. Negative 20x. The 2 and the 10 multiply, and the x just stays there as a multiplier. Same idea, 8 times negative 2x on the left here. It's negative 16x. And then it looks like if I take negative 2x times negative 2x, I know two negatives make a positive. 2 times 2 is 4, and x times x is x squared. So these two factors multiplied become 4x squared. I'm going to combine those x's. So I've got a negative 20x. Maybe I'll do this in a second. Minus 16x and plus 8. Now remember, we still have the multiplier of x on the outside, which I will distribute. So this is 4x squared collecting negative 36x plus 8. I'm going to just pause here for a second to let you know that this is the same answer that I would have got from foiling. This is first. This is outside. This is inside. This is last. The O and L did get reordered there, but it's still the same idea of foiling. The box method or the area method is really a cool new method that you may or may not have seen. I recommend it. We'll see how that works down the road too. Finishing off the problem, I still have an x multiplier that needs to be distributed. So my final standard form answer will be 4x squared times x, 4x cubed. That's the x getting distributed all the way over there. And then the x getting distributed to the negative 36. X makes a negative 36x squared. And then a plus 8x. This is the exact same equation or formula as the factored form is. These are equivalent statements. If I type either one into Desmos, they will be identical graphs. The bottom one is called standard form, and this is how we understand the word polynomial. Polynomial that we wrote down the other day. Whoops, sorry about that. Cool. So here I am at Desmos, and I'm going to type in those two functions. We had first 8 minus 2x parentheses, and then parentheses 10 minus 2x, and then an x multiplier. Notice in Desmos, I don't have to say y equals or f of x equals if I'm just looking at this as some sort of exploration idea. Cool. And I'm going to, let's go back to the home. There we go. Okay, if you use this home button, it takes you right back to the standard screen. And then you can use these zooming in and out buttons or just click and drag. There's other ways of doing that. And you can see there's the top of my graph right at 1.47, 52.5. So that means the biggest volume I could have is about 52.5. And I'd have to cut away. About 1.5 to make that work. So that's what happens with an 8 by 10. I want to show you that it is identical. 4x cubed to the polynomial form, or standard form, they're both polynomials, plus 8x. Cool? And let's see, did I type that? Oh, I got an x. 4x cubed minus 36x squared and plus 8x. And I've just discovered an error. This is awesome. Look, it's not the same. So I went back and I took a look and I noticed, can you see my error? You probably caught it before I did. Oh, this is cool. I like it when I make a little mistake like this, especially if it's just a transfer mistake. That's not too big. Look at that, 80. And look what I wrote, 8 and 8x. Oh no, that was a cool mistake. I just transferred. My brain didn't catch it all. So those numbers were 80x. Do you know how I knew this? This is cool. I knew this because I saw the green graph didn't match and lay on top of the blue graph. Let me put that 80x in now. Oh yeah, see? Same graph, same maximum point. Would I get a different graph? This is a question I have here. What if I wrote the terms in the different way or a different order? Would I get a different graph if I wrote 80x, okay, minus 36x squared? 36x squared. Make sure the negative goes with that 36x squared. Okay, make sure the negative goes with that 36x squared. And then wrote the 4x cubed last. No, that's the same graph too. That's the same exact function. Same exact set of points. That's just an example of commutative. Reordering does not matter. One last thing I want you to see about this. Notice the exponents. The exponents on x are all whole numbers. They're all whole numbers. And we talked about what a polynomial is. A polynomial is a function that is a sum of terms. In other words, terms that are separated by plus or minus signs. So for instance, a 4x cubed, that's a positive technically, minus a 36x squared plus an 80x. That has three terms, three things, three expressions separated by plus and minus. So that's the word terms. And notice the exponents are all whole numbers. Even the one with no exponent up there, that has a 1 on it. All right, let's try another one real quick. This is the playground one that we did before. Let's build the area. Same situation, 200 feet of fence. The fence is right here. We got fence on this side and all the way around. There, and way over there. And then this is our building. And let's build the biggest playground. So let's say I cut away x and x. Or cut away. I'm used to the other problem. Let's say I lay out x length of fencing here. And then what's left over after we take, if we have 200 feet total? Well, I have to take away those two x's on each side. So what is the area then? Area is width times length. Width times length. So in this case, this would be 200 minus 2x times x. Let's put this in standard form. Let's distribute. Let's write it as 200x minus, that's a negative times negative, 2x times x is x squared. I could rewrite it like this, or I could put it in a more standard form. Standard form likes to have the largest exponent first. So I'm going to rewrite this area of x as a negative 2x squared plus 200x. Cool. Let's see what the biggest building will be. Let's Desmos this thing. So I've typed in this equation on Desmos, but I can't see where the graph goes. It looks like just a vertical line. I should investigate. I'm going to zoom out. Always good to just back up and take a look at the world. Okay, now I see. Wait a minute. Is this one of those parabolas? I think this is a parabola. X squares make parabola. Parabolas are polynomials. That's interesting. So I went hunting. I mean, I had to hunt for it. I clicked and dragged And I finally found the top of this, the vertex.